Welcome to Klein's Geometry. Today we're going to be talking about deductive reasoning. Deductive reasoning is like the stuff you see on CSI or any of those detective shows. It's where we use logic. Can't spell today. Logic to figure stuff out. And that means we base our decisions, decide using facts, definitions, theorems. The things we know are true. And then we take that to deduce what else can be true. Now, how does that differ from inductive reasoning? Let's take a look. There is a myth that you can't touch a baby bird that falls from the nest because mom will disown the baby if she detects human scent. I know you've all heard that. But here's what you might not know. Biologists have shown that birds can't detect human scent. Therefore, the myth is false. What kind of reasoning did we just use? Well, this is a fact. We used a fact. So it's deductive reasoning. Now, here's an example of inductive reasoning. You guys know I have horses. Well, every spring, the kids get a little relaxed and they open the gate and let the horses in. And all winter, the horses have been really cold, so you open the gate, they run into the barn. Well, spring comes, it's nice and warm. And inductive reasoning would say you open the gate, they run into the barn. So that's what we expect to happen. But spring comes, you open the gate, they run out into the yard, tear it apart. They were using inductive reasoning, not based on facts, just based on experience. And that reasoning sometimes has a little flaw to it. Okay? Now, using deductive reasoning based on facts, here's what we can do. We've got two laws that I want to talk about today. The law of detachment and the law of syllogism. Law of detachment is simply this. Oops. It says if P implies Q is a true statement. So I tell you something that's true. And generally this is a general case. And then I tell you specifically P is true. Specifically. That's a specific case. We can conclude that Q is true also specifically. I'm not spelling well today. Okay, here's an example. Generally, if two segments are congruent, then they have the same length. That's true. That's P implies Q. P, two segments are congruent. True, Q, then they have the same length. Now, that's a general case, so now I'm going to specifically say, guess what? Segment AB is congruent. I need a line over there for it to be segment. Segment AB is congruent to segment XY. So what can we conclude? Well, we know that if they're congruent, they have to have the same length. So we can conclude that AB, the length from A to B, equals the length from X to Y. Remember, when you don't have the segment symbol, you have an equal sign. That means lengths are equal. So we know if this particular pair of segments is congruent, then this particular pair of segments is also equal. That's going from the general case up here to specific case. So that's our law of detachment. Another example might be if the dog sees the cat, then if dogs see cats, then dogs will chase cats. Generally, that's what happens. Now I'm going to tell you, my dog Gus, he sees cats a lot. We have 5 living in the house. What can we conclude? We can conclude Gus chases cats. So again, we went from a general case to a specific. That's our law of detachment. One general statement, true. We can conclude specific cases are also true. Law of syllogism. That's the last one we want to talk about. Okay? And the law of syllogism says if P implies Q is true. So that's what we've got here. A conditional statement, and Q implies R is true, then we can conclude that P implies R. Now, what does that mean with all these variables? It means that when we look at two statements, we're looking for a link. And when we see it, we're going to cross it out, and what we have left is a conclusion. That's what we're looking for. Here's an example of our law of syllogism. If the measure of angle A is less than 90 degrees, then A is acute. So we have P, we have angle of 90 degrees, and we have a conclusion. Now here, if angle A is acute, notice same, then it is not a right angle. Well, to get our conclusion, we just cross out the ones that are the same. So this comes after then, this comes after if. We're going to cross them both out, and what's left is our true statement. If the measure of angle A is less than 90 degrees, then it is not a right angle. I'm going to run out of room. A right angle. So that's what you would do for your law of syllogism. You just look at what you've got that's the same, cross it out, and it's got to be an if and a then. And then whatever if and then you have left, that is your valid conclusion. Okay? Now, you won't always see them in order. So you have to be kind of careful. Now, take a look at this. Gus is my dog. He's a puppy. He's kind of fun. If Gus goes outside, then Gus will run. That's a true statement. If cats go outside, then Gus goes outside. He likes to follow the cat. Now, notice these are not the same. But do I have two parts, an if part and a then part that are the same? And you'll look a minute and you'll go, yes, Mrs. Klein, look. Gus goes outside. If Gus goes outside, then Gus goes outside. So we can cancel those out. And what's our conclusion? Well, if cats go outside, then Gus will run. And that is hilarious to watch him do it. He runs, he jumps on the cats, he gets them all wet, chews them up a little. A lot of fun. So, law of syllogism, be careful. Just look for the two statements that are the same. Cross them out, and what's left is a valid conclusion. Law of detachment. Start with a general case, P implies Q, and a specific P, like segment AB is congruent to segment XY. Then you can look at the conclusion in your general case and apply it to the specific case. The length from A to B equals the length from X to Y because congruent segments have the same length. When you're looking at deductive versus inductive reasoning, remember, deductive, just the facts. Facts, definitions, theorems. Inductive, remember, that is based on personal experience. Like when my daughter looks and says, oh, those horses will go in the barn. No, they won't. It's nice out. Now they're going to run. So what you see, what your personal observation is, that's inductive. Deductive, just the facts. So hopefully this will help you. You're going to notice your homework assignment a little bit like an English assignment, but I also know you are up for the challenge. Write neatly, or I will not be able to read it and will not be able to award a grade. Have a great geometry experience.